Welcome to the 14th episode of the Grand Cosmic Story. Did all living things descend from a single-cell bacterium-like organism, the last universal common ancestor? Did life begin somewhere in the sea, then crawl out of the ocean to become humans like us, developing skulls and backbones? Are we the product of time plus matter plus chance, or the product of an intelligent designer?
Are you curious about the world around you? Do you wonder what else is out there beyond our world? Dr. Latha Christie, a scientist and an author, will take you on a journey through the universe. Join her in exploring the universe through her web series, The Grand Cosmic Story. Stay tuned to find out what today's episode is all about.
Darwin's Tree of Life is one of the most famous drawings in the history of science. Darwin sketched this tree in one of his notebooks after his return from his voyage on HMS Beagle as the first visualization of the theory of evolution by descent. The idea is that all life on Earth is related by common descent. He believed that the pattern of similarities and differences in species today fits into a tree-like pattern of nested hierarchy where branching points correspond to the appearances of new traits. 20 years later, when Darwin published his book On the Origin of Species, his small notebook sketch had grown into the phylogenetic trees still used by biologists in the 21st century. Many believe that the phylogenetic tree stands as one of the strongest pieces of evidence for the development of life progressing entirely through undirected natural processes. How are such trees constructed? Biologists use a combination of data from a variety of sources to construct phylogenetic trees and to estimate the age of each clade or specific biological group. The data includes morphological data, fossil data, and molecular data, especially DNA sequences. Initially, the trees were constructed and the evolutionary connections that exist between different organisms were made mainly based on the morphological characteristics. Morphology is the study of the sizes, shapes, and structures of plants, animals, and microbes, as well as the interactions between their parts. The word morphology originated from the ancient Greek words morph, which means form, and logos, which means word, study, and research. Later, it was found that morphological data alone is not very reliable in predicting the close evolutionary relationship between species. For example, two unrelated species which have to adapt to living in similar conditions end up developing similar features like the sugar glider and the flying squirrel. Bats and whales use echolocation to make high-pitched noises and listen for returning echoes to navigate and hunt. But this trait is absent in one family of bats called the fruit bats that does not have this echolocators. So morphology alone is not sufficient to construct such trees. The next method that scientists use to construct such trees is the data obtained from fossils. However, fossil data is not reliable. Some of the reasons that it is not reliable are: firstly, an organism becomes a fossil only under certain conditions. It cannot be fossilized if exposed and decomposed after its death. For an organism to become a fossil, it must not decompose or be eaten, but it should be buried soon before it decays. Different species have different propensities to fossilize. Secondly, the fossil data is very patchy and incomplete, making it difficult to work out what evolutionary changes happened and when. Most fossils preserve only teeth and bones, although a few show the features of soft tissue such as stained impressions of internal organs. Birds have light, hollow bones, so naturally few fossils of birds have been found. Plants are problematic because their pollen, leaves, stems, and roots do not necessarily stay together even while they are alive. Surprisingly, although rodents are the most common mammal today, there are hardly any fossils of them. Among apes, the orangutan is the only great ape with a good fossil record. When Darwin brought in his theory of evolution, he believed that he would find support for his theory once they found enough fossils. But now, more than 160 years over, we have sampled enough, and what we found was contrary to Darwin's prediction. Let's suppose while having your daily morning walk along the beach, you collect the things that the wave washes to the shore. As you keep collecting the things, you might find it boring if you only find over and over again what you already have found. Regarding the collection of fossils, many paleontologists feel that they have sampled enough fossils but keep getting similar types. Finally, paleontologists face issues with fossil dating techniques. Biologists use three techniques for estimating the ages of fossils: biostratigraphy, radiocarbon dating, and thermoluminescence. Biostratigraphy is one of the earliest scientific dating methods. Since layers of rock build one on top of another, if you find a fossil or artifact in one layer, you can reasonably assume that it is older than anything above it. Since different species have different propensities to fossilize and the amount of rock fluctuates over geological timescales based on the nature of the environment that it preserves, fossil dating using this method is not accurate. In radiocarbon dating, radioactive isotope carbon-14 in bones or a piece of wood is measured to calculate the date of fossils that are less than 50,000 years or so. By measuring the ratio of the different isotopes at the time of death and the ratio today, researchers can figure out how much time has passed. Unfortunately, it's not straightforward to determine, as accurate calibration is difficult. Also, samples need to be thoroughly cleaned to remove carbon contamination from glues and soil before dating. These are some of the issues with radiocarbon dating. Thermoluminescence dating is used for materials where radiocarbon dating is not available, like sediments, certain kind of rocks like silicate rocks, and organic materials such as coral and teeth. Such materials are very good at trapping electrons from sunlight and cosmic rays over time. Researchers can measure the amount of these trapped electrons to establish an age. However, the complex history of radioactive force on a sample is difficult to estimate, and the measurements are inaccurate, leading to errors. That is why it is challenging to construct the tree of life as predicted by Darwin using fossil data. The third is the molecular clock method, which uses genetic information to compare one species with another, and scientists started to use this method after the discovery of both protein sequences and DNA sequences in the late 1960s. The molecular clock method measures the time from random changes or mutations in DNA by comparing the sequences of a protein and counting the number of positions where the two sequences differ. If you have a start date and know how many genetic mutations there are in a certain period of time, then you can calculate the last time a sample of DNA sequence diverged. But the problem arises when it comes to dating such phylogenetic trees. Dating a phylogenetic tree involves calibrating the tree and establishing the time of divergence of species. The calibration is done using various ways, like the ages of fossils, geological events that have shaped biogeography, or ancient samples. However, since the estimation through fossil data is not accurate, the calibration using that data ends up with major distortions. Sometimes the molecular clock is found to tick too fast, suggesting an older lineage than that suggested by the fossil record. Many scientific research papers have reported twofold differences between the dates estimated from molecular data and those from the fossil record. Also, different approaches to molecular clock method have given dates that differ by 20-fold. Researchers are puzzled by this wild disagreement. They were also not able to use the gene sequences to construct an evolutionary tree because the different genes tell contradicting evolutionary tales. Scientists end up from different genes, different evolutionary trees that often have conflicting branching patterns. One gene gives one version of the tree of life, while another gene gives a highly different and conflicting version of the tree. Summing up, researchers say that phylogenetic conflict is common and frequently the norm rather than the exception. Thus, with the molecular clock method, it's very difficult to find true dates when species diverged. Thus, the construction of the phylogenetic tree is not accurate. So now we end up with a question. Do all life forms fall within a nested hierarchy? Biologists have found that many organisms that could not fit into a phylogenetic tree, and hence they have rejected this idea of a single progenitor as the common ancestor to a clade. The central tenet of modern evolutionary theory that all living things now on earth trace back to a single common ancestor is shaky. Hence, those who hold on to the tree of life now adopt various mechanisms for explaining the deviations from the hierarchy, such as horizontal gene transfer, incomplete lineage sorting, differential gene loss, gene resurrection, gene flow, and convergent evolution. The final question. There is a pattern of similarities in different groups of species. How do we explain that if we do not use evolutionary theory? Winston interprets the relationship not in terms of the most recent common ancestors, but in terms of shared modules. He says that the similarities among various species appear to be the result of a designer reusing design modules in different species to meet common goals. This appeals to common design instead of common descent for explaining the similarities, thus revealing that an intelligent designer may have reused or redeployed the same module in different systems without necessarily having any physical connection between those systems. Even more simply, intelligent causes can generate identical patterns independently. Many are aware that Darwinian evolution is a controversial topic because of religious beliefs, but few realize that it is also controversial because of disagreement based on scientific evidence. Almost all scientists believe in small-scale changes in a population of organisms, which is called microevolution. However, there are many scientific skeptics when it comes to universal common descent, the origin of life, and the unguided process of evolution or macroevolution, giving rise to large-scale changes and the complexities of various life forms. The idea of universal descent, that all organisms are related to one another because they all descended from a single common ancestor, is far from convincing. The tale of human evolution that has been portrayed in diagrams of branching trees and of progress happening in steady steps seems like a fairy tale, painting an artificially elegant portrait of life's pilgrimage. G.K. Chesterton says, "Man is not merely an evolution, but rather a revolution."
When I consider your heavens, the work of your fingers, the moon and the stars which you have ordained, what is man that you are mindful of him, and the Son of Man that you visit him? For you have made him a little lower than the angels, and you have crowned him with glory and honor.
Bye for now. See you again in the next episode. Let's explore whether the information in our DNA and the complexities of our cells happen by chance or by design.